Hello, Math 125 fans. I'm teaching Calculus 2 this term, and as we get towards the end of the term, I find that certain students panic about something we did much earlier in the term, which is labeling graphs. It's such an important skill, and I've actually made several videos on this, but I'm going to make yet another one. Sometimes it's just a matter of labeling, but I'm getting a question on the discussion board, and it has a picture like this. Now, I asked the student which exam it came from, and the one they told me doesn't match the one in the archive. So I'm just going to deduce what it is that was given from the picture. So I think the function was y, and then we'll do several more of these. My goal is just to do as many examples, because the setup takes very little time, so I can do a lot of examples in a short amount of time. But I think this was the function, just based off of the picture they provided in their work. Yeah, that's the function. It looks like this. So that makes this 2, because when you plug in a 0, you get a 2. And this was a 1. And let me draw it a little better. And I'm sure that the question was about doing various volumes, but ultimately, and this is what was worrying the student, is they were getting worried about how to rotate around this line y equals -2. And the issue they were having was they just were not labeling. They're not understanding their labelings correctly. So let's go through that. So if you do this problem, you have two approaches, and this skill of labeling is so incredibly important. I mean, I wish I could just stop everything and say, only focus on this. Because if we're not getting this, it's going to really hurt us for a long time in many math courses. We have to be able to label a graph correctly. So let's label this graph correctly, and that's how I want to go through this, and then we'll do a whole bunch more in the rest of this video, and I'll do those quicker. But this first one I'll take a little more time in explaining. So I would like to label everything in terms of x, which I think was part A of the exam. So if you give me a random x, I would like you to label this. What is that length? I would like you to label this. Let's use a different color. I would like you to label this. What is that length? I would like you to label, and you should take your time and don't move forward unless you are absolutely 100% certain that you have labeled that correctly. And I think someone who's done their work and done their homework can do that. So here's another one. What if I label this y? And I ask you to label the following. This length, let's mark that. This is really what most of the challenges, when I see students have challenges with this, it's because they're not labeling correctly. And that's not really a calculus skill, it's understanding how to work with function skill, which I would say is more important than anything we do in the calculus. And I would label this. Should use a different color. So before you would start any of these questions, you would need to label some examples. So hopefully you've done that. I'll then go back and fill in. And my personal preference is to make everything a positive number and then worry about this. And that's what the question was about. So I'll address that in a moment. But I would label this, the length is 2. I know that's a -2, but I would just label the lengths. And that's the same as this length over here. This length is 2. That part doesn't change. The height, that's what we mean when we say this is the graph of this function, is we mean this height is 1 plus e to the x. Now some students prefer to label this y equals 1 plus e to the x and think of it as a dot, meaning x comma 1 plus e to the x, and that's perfectly fine. So if you want to think of it as a dot and what the value of that, the height of that dot is, that's fine, or you can think about it as this length. Some people like to label this dot, and they like to label it x comma -2. And so in my previous video, I talked about if you're someone that absolutely loves doing top minus bottom to label lengths, then you got to leave the negatives in there. Or if you just like to do lengths, you can just say, what I would say, 3 plus e to the x. I would add those two things together. But if you're going to do top minus bottom, it's going to be 1 plus e to the x minus negative 2, which is 3 plus e to the x. It doesn't matter. The question on the discussion board is, why is I not getting the same answer? It's not that it's not correct to do that. They were subtracting in the wrong order. Okay, so that's the labeling. So notice I haven't talked anything about the volume yet, because the skills we just talked about there have nothing to do with the volume or revolution and just have to do with labeling. So let's continue practicing our labeling skills and see what we can label here. This is what? We have this function y equals 1 plus e to the x, but now I'm giving you the y and I want to know the x. That's what this is. I am giving you the y and I want to know the x. So we need to rearrange this. It's y minus 1 is e to the x. So x is the log of y minus 1, and that's what you would label this. Log of y minus 1. If you're someone that loves to label points, then instead of labeling the length, you would label it log of y minus 1, comma y. And you would label this dot, 0, comma y. If you wanted length, it would be right minus left, which is just log of y minus 1. The other length is 1. So I personally like to make a schematic, whether I visually see it or not, that removes all the negatives and just gives me some lengths. And notice that some of these things, like I should have labeled one more thing, which is how far is it from here to here? And that's still going to be top minus bottom. If you love doing top minus bottom, you can. But I personally would just look over here and I would say it's y plus 2. If you do top minus bottom, you'd have to think about that the y coordinate here is y, and the y coordinate here is negative 2, and it would be y minus negative 2, top minus bottom. Still the same thing. And that's really what the person was asking. But again, this is so fundamental, I just want to hammer this down. So that's the thing. We have to be able to make those labels and understand what we're given. Okay, now let's actually talk about the volume. So in this volume question, we're rotating around y equals negative 2. If you do it in terms of x, which is easier, I'll talk about why it's easier in just a second, you should realize that that's the washer method. And we did quite a few of those, but let's try to draw this here. So you say, okay, we have this region. If you take this dot and rotate it around, that gives you an inner circle. So that 2 is the inner radius. And if you take this and rotate it around, it gives you this outer circle. And there's a little bit of thickness, blah, blah, blah. Integral from 0 to 1, dx, it's a washer, pi times the outer radius squared minus pi times the inner radius squared. So now we're going to shift gears into how do we get what we want from what we're given. We already drew what we were given. The inner radius is how far, if you stand at the middle, right here, and start walking towards the region. This was the region. And when you first get to the region, that's your inner radius. And we have already labeled that 2. And then when you walk from this point to the outer edge, that's this yellow thing, that's your outer radius. Done. Now the problem with working in terms of y is the picture I just labeled is not accurate for the entire region. It's only accurate above 2, if you'll notice. If you're below 2, I wouldn't have even been touching the orange curve. So if I'm below 2, let's draw that example. Do that labeling. So I did not draw a general enough picture. I knew I was doing that. I was trying to just focus on one problem at a time. But if I had labeled this y, let's think about how the labeling would be different. Y equals negative 2. This would still be 2. This now would be 1. And you wouldn't be touching the orange graph. So the problem with doing a volume or revolution here is if you start with something in this region, you're going to get a shell. But the height of that shell is always going to be 1. As opposed to this one, you're going to get a shell. and the height of that shell. What a terrible picture. It's hard. This is why I don't like drawing on a screen like this. It's just hard to draw some of these things. But anyways, here the height is going to be however far it is from there to there. So I'm going to need to label that. Okay, so let's erase that. Erase this. And this. Okay, so here's what we're going to do. We're going to say from 2 to wherever in the world that is. Let's see, if I plug into 1, I get 1 plus e. It's shells, but we're going to need to fill in some pieces. And then from 0 to 2, it's also a shell, and we're going to have to fill in those pieces. And there's no, if you were doing this question yourself, there's no reason to do both of them. You would just do this and be done. But I think the exam question was asking for both, and the student was specifically asking about part B. So for part B, the radius of the shell, which is how the radius is always going to be, you stand in the middle and you walk to the edge of the shell. It's that yellow length. And you can see in both scenarios, it's y plus 2, which you can think of top minus bottom, which is what the student was concerned about. But if you're thinking of it as top minus bottom, it's this. It's still y plus 2. Or you can think about it as lengths. The height is however far it is from there to there. So we have one last bit of reasoning. We have this 1. We have this log of y minus 1, and we want to know what this is. And that's why I like to work with positives, is because once you've labeled it, it's fairly clear what the answer is. It's 1 minus log of y minus 1. That's that length. That's the height of that. Whereas this one goes all the way across, so this is just 1. So this together should be the same as that. Okay, so let's do several more. In trying to find this student's question, and I never found it. I looked through almost all the old finals. I couldn't find their particular question. I probably just passed right over it. But I found many others, so I just started throwing them in here as I spotted them. So this really should be something. I think if you prepare, it's a very important skill, number one. And it's just something you can do pretty well if you prepare for it. It's all about labeling. So here it says above the x-axis between 4 and 9, about this line, find the volume. So it doesn't say which method to use, but hopefully you realize you desperately want to use x. This is very similar to the other example we just did. And so now I'm going to be on a mission to label everything in terms of x. So here's a random x in my region. And now I want to label how far this is. And I'm going to rotate that around, but I'll deal with that in a second. The key thing is to label this length. And that's easy. That's what the function tells you. It's e to the square root of x over square root of x. The other thing we might want to label is how far we are from this axis of rotation. And that's where I would label this as a 1. Now, if you want to do right minus left, you can, but you'd have to think about this being the point x, comma, 0, and this being the point -1, comma, 0, and you would have to do right minus left. And right minus left would be x minus -1, which is x plus 1. Or you can just think about them as positive numbers and still get x plus 1. Okay, so at this moment, you should see that it's a shell, and now I'm ready to do the whole problem. The integral from 4 to 9, 2 pi times the radius times the height, dx, and I'm basically done. Because the radius, we just said, is x plus 1. The height is e to the square root of x over square root of x. Once you know how to label and what you're going for, these become very fast questions. And I think you had to do integration, but in this video, I'm not focused on the calculation. Let's do another one. Winter 2018. Let R be the region bounded by these curves. Find the volume of the solid rotating around the y-axis. Okay, I want to use x. I see that right away. Why do I want to use x? Because there's a clear top bottom. If I do left and right, I'm going to have to split it up a whole bunch. So Step one, I'm going to label a random x here, and then I would like to label everything else. Now it's a little small, but this y value must be this function, x squared minus 1/2 x to the fourth, and this x value down here, y value, should be negative 2x. And if I just knew where they intersect, it told you where they intersect, 0 and 2, I should realize that I want to use x. All right, there's a shell. And so I'm pretty much done. 2 pi, radius, height. The radius is how far it is this way. And again, part of the problem is the picture's kind of small, so let me exaggerate the picture a little bit. Here's x. From here to here is that radius of my shell. And then I need the height. The height is what's going to be from here to here. It doesn't matter that it goes into a negative region. You just need to do either top minus bottom or label the lengths, however you want to think about it. But the top is this one, and the bottom is the other one. So top minus bottom is going to be this. And so we're going to have x squared minus 1/2 x to the fourth plus 2x. And the radius is just x in this case. Okay, what about if we rotate around the horizontal line y equals 2? So again, we want to use x. We desperately want to use x. If you don't use x, it's going to be really hard to describe the lengths. This is all about labeling. If I label this x, we now know the distance to my function is given, distance to this top function was given to us. It was the x squared minus 1/2 x to the fourth. And we know that this length is given by the other function. Okay. So we want to use x, and we have those labeled. So we have that little spot labeled, x comma, whatever we said it was, 1/2 x squared, not 1/2. X squared minus 1/2 x to the fourth. And we have this dot labeled as x negative 2x, and we're rotating around the line y equals 2. And so you should first see that now we're talking about washers. How do I know we're talking about washers? If you take this point and rotate it around. The other thing we talked about was perpendicular. I mean, there's so many things we could say here, but I've made other videos about it. Let's focus on the labeling aspect. So we should be saying the integral from 0 to 2 pi times the inner radius squared minus pi times the outer radius squared dx. The inner radius is going to be however far it is from the radius axis of rotation to here. So I need to label this. So we get to play this game yet again. You can either do top minus bottom, in which case it's going to be 2 minus this formula. So 2 minus x squared minus 1/2 x to the fourth, which is going to be 2 minus x squared plus 1/2 x to the fourth. And that's the inner radius. Or you could label and say this is 2, this is what this function is, and so it's 2 minus that. Both tell you the same thing. The outer radius is how far it is from here to the outer edge, which you can think of as top minus bottom, which would be 2 minus negative 2x, or 2 plus 2x, or you can think of it as labeling. This is 2, this is 2x, turning everything positive, 2 plus 2x. Okay, let's see some more. Let's keep going. Okay, this is an unusual one I just found, but the cross sections here are triangles, and so the very first thing you do is this, 1/2 length times height. So remember, if it's not a disc or washer, it's just whatever that is. So this question was about labeling this, but they told us this length was x squared. And they told us this length was 4. So this is one of these questions that's an easy, hard question. Meaning it's hard simply because it looks different, but it's easy if you just follow the idea. Set up an integral to equal to the volume of the solid obtained by rotating this around the x-axis. Okay, this is mostly just, can you keep your head without going crazy here? It's not. I think if I was going to do this question, I would probably do washers. I'd probably do it in terms of x. I don't know, without thinking about it a little more, what would be better. I think either way it's fine. But you'd have to see that, okay, it's the integral. What's the biggest and smallest x can be? I guess it would be -2 to 2. I got that by just thinking about if this were 0, what is x? So it'd be a little bit of work on some of that. But I'm going to do pi times inner radius squared minus pi times the outer radius squared. And then the labeling that I need to do is to find these two things. Based off of x, how far is this? And how far is this? And you might go, well, how am I going to get 2? There's only one formula. Well, don't worry about that yet. Just start solving for y in terms of x. And you get y minus 2 squared is 1 minus x squared over 4. And so you get y minus 2 is plus or minus. That's where the two answers are coming from. X squared over 4 is 1. The other one is y minus 2 is negative square root of 1 minus x squared over 4. And so you're going to get 2 plus this. That's the further one because it's bigger. So 2 plus the square root of 1 minus x squared over 4. And 2 minus the square root of 1. So these questions were both semi-straightforward, but they looked different. So students probably were worried about them. But I would argue that those were shorter. What do we have here? Let this be the region of the first quadrant bounded by this. It's an unusual function, arctangent, and this line square root of 3. Calculate the volume rotating around the y-axis. I think probably either method works here. I'm almost certain. So you could do it in terms of x or in terms of y. So meaning you just have to start labeling whatever you're going to do. So you could label x step 1, or you could label y step 1, and then label everything in terms of that. So let's do that question. This is 0. This is y equals 3 arctangent of x. So there we go. If you use that method, you should realize that gives rise to shells, because if you draw an approximation here and rotate, it's a shell. So anyways, you'd have the integral from 0 to root 3. We said this is going to lead to shells, dx. The radius is x. The height is the function. So that's going to work perfectly fine, but you're going to have to do integration by parts. If you prefer to label things in terms of y, you absolutely can. And this is, you'd have to label this length, which hopefully you can see as square root of 3. And you would have to label the length to your function. You might say, why do I have to label those? Well, because it's going to be a washer, if you rotate that around. And one of them is going to be the inner radius, and one of them is the outer radius. So if I did in terms of y, it's going to look like the integral. The smallest y can be a 0. The biggest y can be, we have a little bit of work. You have to think about when is the square root of 3 equal to 3 arctangent. That would be a good time to have something on your unit circle. So basically you're trying to figure out... Sorry, I plugged it in the wrong place. Let me fix my error there. I apologize. This is x, so I got to plug it in for x. Y is equal to 3 arctangent of root 3. So you have to think about when is sine over cosine equal to root 3. And that's when sine is root 3 over 2 and cosine is a half. So sine is that's pi over 3. So anyways, there's a little side job there. But the thing I wanted to focus on in this video is labeling. So let's just keep going with this theme. The inner radius is how far it is from there to there. So I need to take this equation and rearrange it. That's not too bad. That's the inner radius. So it's going to be tangent of y over 3. And the outer radius is square root of 3. Okay, let's keep going. So you can compute either one. Yeah, the second one you can do a little trig identity and it'll come out kind of nice. So maybe they're about equal. Here's yet another one. Set up an integral for the volume swept out by rotating around the y-axis. So once again, this is one where I desperately would want to use x because you can see the right and the left change, whereas the top and bottom don't. They told me that this length was given by this formula, and so now I know that it shells. So it's the integral from 0 to 1, 2 pi times the radius of the shell times the height. The radius of the shell here is x. The height is the function. Done. That was short. Okay, now let's say we want to rotate around the line y equals 2. We still want to use x, so let's label a random thing x. We still know that this is the function, but unfortunately that's not what we want anymore. We want some other stuff. So let's label, if I was me, I probably would be thinking about what can I label this and what can I label this? Well, that's 2. This is the function, x squared minus 2x plus 2. And that must be the difference. You can think of it as top minus bottom. But in this case, what are we getting if we rotate around? We are getting a washer. So it's the integral from 0 to 1, pi times the outer radius squared minus pi times the inner radius squared dx. The inner radius is going to be however far it is from here to here. So that yellow labeling is the inner radius. It's always, if you stand on the axis of rotation and start walking directly towards your region and you hit it, that's the inner radius. In this case, it's going to be 2 minus whatever the function is. So 2 minus x squared minus 2x plus 2. Well, it's kind of nice because the 2's cancel. And then the outer radius is just 2. So that's how far that is. Keep going. Here's yet another one. Set up integral to the volume of the solid formed by rotating this around the y-axis. I would want to use x here as well because the right side changes. If I'm using x, then I'm using cylindrical shells. And so it's the integral from 0 to 2, 2 pi blank blank dx. The radius is x. The height is the length, which is between those two functions. The function on top must be the cubic because the other one's the line, so you get 9x minus x to the third minus 2x. Done. Find the volume obtained by rotating around the line y equals negative 5. So there really shouldn't be any more panic about a different axis. We still want to use x. We know this is that line, so that length is 2x. They told us that. This length from here to here is the 9x minus x cubed. 9x minus x cubed. And this length right here is 5. And I like to make everything positive because then I can just read off the answers. It's perpendicular to the axis of rotation. We're still doing the integral from 0 to, I think it was 2. And then it's going to be pi times the outer radius minus pi times the inner radius squared. The inner radius is 5 plus 2x, so 5 plus 2x. Again, stand on the axis of rotation and walk till you hit the region. The outer radius is 5 plus 9x minus x to the third. Keep going. All right, a weirder question. It says the cross sections are squares. Okay, so whatever's going on in this question, it's going to be length times width, dx. So we will ultimately have to label how far this is. That's the length. It's this length along the bottom. And since it's a square, these two things are going to be the same. So as much as going on there, and this looks worse than it is, you're going to have to take this thing and rearrange it in the y equals form. So you're going to have y equals over b squared. There's a lot to read there. I think this question went terribly for students. I have a vague memory of this happening. We had a particular instructor that really wanted to ask this question, which was fine. but students were not very happy. So then you get plus or minus the square root of 1 minus x squared over a squared. The plus is how far it is from here to here. The minus is how far it is from here to here. So this length, L, is 2 times the square root, times b, times the square root of 1 minus x squared over a squared. And since that's the length, it's also the width. So it ended up just being the integral from negative a to a of 2b square root of 1 minus x squared over a squared squared. But that's kind of a very special type of question. I just finding every one I can. Okay, so there's a whole bunch of those. I hope something there was valuable. It's just such an important ability to be able to label a graph and understand what you're given and what you want. I just wanted to make one more video to hit this home. Let me know if this helps.